Hey everyone, welcome back. Ever wish you could like predict the future? Like
Mm,
know how much money you'll make or how fast your investments will grow?
right, right.
Well, today we're going to dive into something called data fitting.
Okay.
It basically helps us make those kinds of predictions.
Cool.
We found this really cool tool from Open Educational Resources, Open Source Physics at Singapore.
Interesting.
It's a JavaScript applet,
Yeah.
and it lets you play around with data fitting and curve fitting.
All in your browser.
Yeah, or in your browser.
That's awesome.
So it's like
It's like a virtual
yeah,
sandbox?
yeah.
You can add your own data points. You can see how they cluster on a graph, and then you try to find the curve that best, represents them.
So this is way more interactive than just like staring at a spreadsheet.
Absolutely.
Yeah.
Yeah, it's more engaging.
Okay, cool.
So this applet focuses on fitting polynomial curves.
Now I'm a little rusty on my math.
Oh, yeah.
Remind me what a polynomial curve is.
Oh, so, imagine drawing a line through your data points.
Okay.
So that's the curve,
Hmm.
and a polynomial equation gives us the math behind it.
Right, right.
Could be a straight line or it could be a curve,
Okay.
depending on the data.
So how do we find like the best curve? Because I can imagine lots of different lines that might kind of fit.
Right, yeah, so that's where least squares approximation comes in.
Okay.
Imagine drawing lines from each data point up to the curve.
Okay.
Least squares tries to make the sum of the squares of those distances as small as possible.
Hmm.
It's basically finding the curve that is closest to all the data points.
Like the snuggliest curve.
Yes.
I get it. And the applet has a best fit button
Yeah.
that shows that snuggling curve.
Yeah, it does.
Okay, cool. So like how does the applet calculate all this? Is it magic or something?
Well, it's not magic, but it does involve math.
Math.
Yeah, so the applet uses a NumericJS model element,
Okay.
and this is basically a tool that solves the equations behind data fitting.
Equations. You're not talking about like high school algebra equations, are you?
Well, yes,
Hmm.
but these equations are what help us determine the shape and position of the curve.
Cool.
They're like a recipe.
Hmm.
Like each ingredient represents part of the equation.
Okay, okay.
And when we adjust those ingredients, we can adjust the curve to fit the data.
So the applet is like doing all the math in the background while we're playing with the visuals.
Yes.
Got it. So I noticed this section called For Teachers Curve Data Fitting.
Oh, yeah.
That's where it gets like super complicated.
Well, it goes a bit deeper, but the basic idea is the same.
Okay.
It's still about adjusting the curve to fit the data.
Okay.
But in this section, we're looking at those ingredients more closely.
Okay.
So those ingredients that we talked about are represented by letters A, B, C, and so on
Hmm.
within the equation.
And if we tweak those letters, we're basically tweaking the ingredients in our curve recipe.
Precisely. Those letters are called coefficients. They control the shape and position of the curve.
Okay.
The For Teachers section explains how those coefficients work together to create the best fit.
So it's like a peek behind the curtain to see how everything works.
Exactly.
I have to admit, even with the recipe analogy, I'm still not sure how all those equations work.
Of course.
Can you break it down a little more?
Okay, so let's start with something called a basis of linear independent functions.
Okay.
Think of these functions as like building blocks for our curve.
Okay.
They combine in different ways to create that overall shape.
Mm-hmm.
Think of building a house,
Yeah.
You have bricks and beams and panels that you can assemble in different ways
Okay.
to create different structures.
Hmm. Interesting.
Same idea here.
So like linear independent functions are building materials.
Exactly.
And the coefficients are like the instructions that tell us how much of each material to use.
Precisely.
Uh-huh.
So the applet uses these building blocks to create a curve that fits the data as closely as possible.
But how do we know which combination of building blocks is the best one to use? Is there like a formula for that?
Well, it involves minimizing the sum of squared differences between the curve and those data points.
Right.
And we use a method called least squares fitting.
Mm.
And this is what we were discussing earlier.
Right. So we're back to minimizing those tiny little distances between each data point and the curve.
Right, exactly.
It's pretty cool how everything's connected.
It is. And that connection is what makes data fitting such a powerful tool.
Yeah.
Because we're using math not just to describe data,
Mm.
but to understand trends, to make predictions,
Mm.
even to see into the future in a sense.
Wow. That's pretty deep. I'm starting to see why data fitting is used in so many different areas like business and science,
Yeah, it really is.
and even in our own lives.
Of course.
Wow. I think I'm starting to get this. But just to make sure our listeners are on the same page,
Yeah.
can we do a quick recap of what we talked about so far?
Yeah, absolutely.
So we're talking about data fitting,
Yeah.
which is basically finding the best curve that represents a bunch of data points. And we're looking at this interactive applet
Right.
that lets us see the points on a graph and try out different curves.
Yeah. And to find the absolute best curve,
Right.
we use least squares approximation.
Right.
It's a way to make the distance between the curve and the points as small as possible.
And we talked about how the applet uses equations and functions to make those curves.
Yeah.
And we can change the ingredients of those equations to adjust the curve.
Exactly.
Those ingredients are called coefficients, right?
Right. And the applet does all those calculations.
Okay.
So we can focus on the visuals.
Yeah, I really like that building blocks analogy,
Oh, yeah.
where we use different pieces to build our curve,
Uh-huh.
and the coefficients tell us how much of each piece to use.
Exactly. Those building blocks are linear independent functions.
Okay.
And each function contributes something unique to the curve's shape.
So we can create all sorts of curves, straight or curvy, by combining the functions in different ways.
Exactly. And you can see that in the applet. You can add your own data points, move them around, and see how the curve changes.
That's awesome. So how does all of this apply to the real world?
Oh, that's a great question.
Like, why should anyone care about data fitting?
Well, the applications are everywhere.
Okay.
Businesses use it to predict things like sales and analyze customer behavior.
Right.
Scientists use it to understand natural events and make predictions about the future.
Wow. So this isn't just some abstract idea.
No, not at all.
It's actually used to solve problems.
Yeah, and not just big problems, but everyday ones too.
Like what?
Imagine you're tracking your workouts. You could use data fitting to see if you're getting fitter
Oh.
and maybe even predict how long it'll take to reach your goals.
That's pretty cool.
Or if you're trying to save money,
Right.
you could track your spending and use data fitting to see where you can cut back.
Oh, I need that.
It's all about finding patterns in your data and then using those patterns to make better decisions.
Like a secret weapon for self-improvement.
Exactly. But it's not about being 100% accurate. It's about using data to make better choices.
Right. So we can't predict the future exactly,
Uh-huh.
but we can use data to improve our chances.
Absolutely. And this applet is a great way to start learning how to do that.
So before we go too far, is there anything else we should mention about the applet?
Oh, yeah, one more thing.
Yeah.
We've been talking about polynomial curves,
Yeah, those smooth lines.
but those aren't the only type of curve used in data fitting.
Oh, really?
There are lots of options depending on the data you're looking at.
So it's like having a toolbox full of curves.
Exactly.
Yeah.
And sometimes you need to try a few different ones to find the best fit.
Makes sense.
Just like trying on different clothes,
Yeah.
you want to find the one that looks best.
So it's not just about knowing how to do the math.
No.
It's also about knowing which curve works best in each situation.
Right. It's about finding a curve that both fits the data and makes sense in context.
This makes me really want to try out that applet.
Yeah.
But before we wrap up, maybe we should talk about how to know if we found a good fit.
Yeah, that's a great point.
How do we know if our curve is doing a good job?
Well, there are tools for that.
Oh.
Like the R-squared value. It tells us how well the curve explains the data.
Like a score for our curve fitting.
Yeah. A higher score means a better fit.
But there's got to be more to it than just one number, right?
Yeah, you're right. It's not just about the score.
Okay.
We also have to think about what the data means, why we're analyzing it,
Yeah.
and if the curve makes sense based on what we already know.
So it's like being a detective. We look at the clues, analyze the evidence, and use our judgment to figure out what happened.
Exactly. Data fitting is both art and science.
I like that.
We use tools to guide us, but we also use our brains to interpret the results.
This is really making me think differently about data.
Good.
It's not just about the numbers themselves. It's about what they tell us.
It's about finding the story behind the data.
Wow, I'm really inspired now.
I'm glad.
But this is a big topic.
It is.
And I know we've only scratched the surface.
Yeah, there's always more to learn.
It's like we've opened a door to a whole new world.
And that applet we talked about is a great place to start.
Right. It lets you play around with data and see how it works.
You can experiment and get a feel for the process.
I love that best fit feature.
Yeah.
It's like having an expert show you the best way to fit your data.
It makes things so much clearer.
It shows you that even though there are lots of curves that might fit,
Right.
there's often one that's statistically better than the rest.
Exactly.
So we can't just rely on the software.
No.
We need to use our judgment, too.
Absolutely.
It's like being a detective.
Hmm.
You got to look at all the clues
Yeah.
and use your intuition.
It's not just about the numbers.
Right. It's about the story behind the number.
You got it. It's
Yeah.
about finding those hidden patterns.
And maybe even using those patterns to predict the future.
Exactly.
So whether you're in business or science,
Or just trying to understand your own life.
data fitting can be a really useful tool.
It sure can.
So I think we've covered a lot today,
We have.
from polynomial curves to real-world applications.
And don't forget about using good judgment when you're analyzing data.
Right. That's super important.
I hope our listener feels ready to explore the world of data.
Me too. Don't be afraid of data, everyone.
There are tools and resources out there to help you.
Like that applet we talked about.
It's a great way to start.
Who knows what you might discover?
The possibilities are endless.
That's the beauty of data fitting.
It's a journey of discovery.
A way to find hidden knowledge.
And make the world a more understandable place.
Well said. Thanks for joining us on this deep dive into data fitting.
It was my pleasure.
And to our listeners, stay curious and keep exploring.